Hi everyone, my name is Jamila Awada. I'm from the University of Luxembourg. I'll be presenting joint work with my colleagues Michel Antunes and Björn Ottersten. The work is a revisit to human action recognition from depth sequences. We actually propose a guided SVM sampling for joint selection algorithm. And this work is part of a European project called STAR, where one of the goals is to build a telerehabilitation system for stroke survivors. For this system, we need an efficient action recognition algorithm. For that, we use a Kinect camera. This kind of algorithm can be used for other applications. We cite healthcare, gaming, security, surveillance. So from a Kinect camera, we extract skeletons in real time. This is our initial data. And we follow state-of-the-art pipeline for action recognition from the skeleton representation to temporal modeling and then classification. So the standard representation for a skeleton is basically a set of joints or points in 3D, or a set of rigid parts or body parts. So one question that we ask, the main question we ask in this work is, do we need all skeleton information to recognize a given action? And the observation that was first made by Wang and others in CVPR 2012 is that each subject performs an action using a specific set of joints in roughly the same order. So for instance, for the action of throwing or clapping, you would only need the joints forming the arms. And for the action of kicking, you would only need to analyze the joints of the legs part. So based on this observation, we run this very simple experiment where we progressively reduce the number of joints or joint features used for action recognition. And we looked at the accuracy resulting from this. So what we found out is that we can reach about 99% of the same accuracy using about 50% of the joint features. So this is a huge improvement in the cost and complexity of the problem. So next we proposed an algorithm to select automatically a subset of joints for action recognition for a given action. So we proposed what we call a guided SVM sampling, which is based on two criteria, maximizing confidence and minimizing ambiguity. We ran our experiments on 3 different data sets, and we found out that we basically have comparable accuracy as to other state-of-the-art algorithms while reducing complexity. So next, the goal is to keep the same sampling principle, but using more elaborate representations, skeleton representations. For instance, we're thinking of using the work in Chilapa's team, basically where 3D joints are represented as points in the Lie group, and combining this with the proposed sampling algorithm, we're thinking to reach the same accuracy while reducing the complexity. For more details, please stop by our poster. Thank you.